This is lesson 3 of 1.2.3 units of storage. How do we convert data into binary and how a processor actually interprets the data. Today we're going to be thinking about some of the key words such as digital. Just to recap, remember that binary and a computer can only store data in zeros and ones. This is because a computer is built of either ons and offs, which we represent by zeros and ones. Think of it like lots of switches. And everything on a computer is stored in a binary digit, a bit. A bit is not enough space for us, so we use bytes, which are 8 bits, which are useful for a single character, but not large enough for more data. So we would use kilobytes, where 1000 bits equals 1000 bytes equals a kilobyte. Now, when we think of binary, we think of on and off, and we have said that there are two states. We've been thinking about lights. There's a little video here of a light turning on in slow motion. And actually this light, it does not have two states. When our light turns on, it doesn't turn on straight away, it warms up. And it takes a couple of milliseconds to get to full state. This is our analog system. And we can think of analog systems as using waves. Now this can't work in a computer because it has to be either an on or an off. So we can't have those in between states. It's either got to be on or off. And this is our digital system, a 0 or a 1. Now you might have listened to radio when you're in the car, or you might have used walkie-talkies, and these signals travel in waves. This is an analog signal. Now all televisions used to be analog. Nowadays they're all digital. A computer, remember, works with digital signals. And even if we record using a microphone, an analog signal, remember a computer can only use ones and zeros. So the purpose of a microphone is to capture the analog signals, and then our software turns that into a digital signal. Please find the analog page in your workbook and give me a definition. You only need to complete the top box, and I want you to use the words signals, waves, and you might put more options. Please pause the video and complete your definition. Now we can think of other analog signals such as walkie-talkies, singing, talking, and originally radios, but nowadays more common radios are digital. Fill in the uses box. Find 3 pictures of the devices that would use an analog signal. And then explain why this is different to a digital signal. Please pause the video and complete these 2 boxes. We're now going to think about digital signals. In a digital system, remember, you can only have 2 states, and there's nothing in between that. You've got a mini whiteboard in your workbooks. Please put your answers onto this page for the following items. What are the 2 states in RAM? You should have got no charge or charge, an on or an off. What are the 2 states on a hard disk? Well, you should have got north or south, or on or off. What are the 2 states in optical discs? You should get pits and lands, or on and off. And what are the 2 states on an SSD, a solid state memory? Trapped electrons, free electrons, a charge or no charge, which is an on or an off. What is the name given to a binary digit? The answer is a bit. What is the name given to a non-digital signal? It's analog. Please can you complete the first two sections of the page called digital signals. Now let's think of the advantages of digital. Remember, there are only two states. Now with just two states, this makes it much easier for us to create a computer. Therefore it's much cheaper and much more reliable. Imagine if we had more states. We could represent more data, but that becomes more complicated. There is a lot of work going on in this field at the moment called quantum computing. And if you are interested in quantum computing, you can complete the extended research tasks at the end of your workbook. Please now complete the 3 advantages section of digital over analog. Write them into your workbooks now.